Hi guys, Fraser from LIFCO. This is a complicated one for you. It's a motor, and it's a 2-speed motor that shifts based on an electrical signal. Now it has some other features to it, but let's just focus just on that feature here. In this application, it has a type of control that turns the pump from full displacement to a minimum displacement by pressing a button or something like that. So it's not like a joystick where if you move the joystick half of the way, it would go half of the displacement or half the speed difference. In this one here, it's either full speed or about 20% of it. So that means it's going to go 5 times the speed when somebody presses that button and gives current to the solenoid. So what could this be on? Likely, I would think like a winch type thing, where it's moving really quickly when it doesn't have anything on it. And then as soon as it gets loaded, then they want it to go to a max displacement and it'll move slowly, albeit much more powerfully. Now, we had another video of a 2-speed motor, and it was a gear motor. This is one that we did about a year and a half ago. It's one of our first videos that we made. Why would somebody use this piston motor as opposed to the gear? Well, the piston motor actually isn't all that much more expensive than the gear one. The big difference, though, is the efficiency that you get of a piston. So pistons could be 95%. A gear would be significantly lower than that. But the other one is that you have a consistent starting torque. Because of the way that the gears mesh together, that depending on where they stop, you could have different torque for starting up. It would be very unpredictable, which is not very good if you have something hanging over somebody's head, for instance. The other benefit of the piston is that it's variable. And we saw that on their previous video of the HMA, where it was adjustable. Well, this is the same thing. It's adjustable. We can adjust where we want the max displacement and the min displacement to be. So where we want the slowest but highest torque, the max displacement, or the fastest but lowest torque, the min displacement. So that's entirely adjustable. You can adjust it in the field, but nobody does that. We do it in a shop on that one.
Here we are testing the motor. It's a V14-110. So we have to reach 55 cc per revolution, and we also need to have the threshold setting at 400 milliamps. We just need to make sure it's shifting at 400 milliamps and not before or later.
The way this thing works is that it has a min and max volume and a way of driving it from max to min or from min to max. This one drives from maximum displacement to min displacement.
You said this goes from max to min, so as soon as I turn it on, it just right away.
No,
stop?
So basically what it is, maximum displacement is going to be a slower speed but higher torque.
Okay.
So if you want a heavy load, you want your max displacement.
Okay.
If you want to go faster, you shift it into min displacement and your RPM will increase with the same flow.
Okay.
So this one's actually set at 110 and 55. So if at 15 gallons I've got 500 RPM at max, I put 400 milliamps, I'm now going to go twice as fast because my CC displacement is half. So if I would have gone to say 33 cc's, if I got 500 at max, I'll have 1500 at min. On this one, this is a 2-position electronic control. So at a predetermined voltage signal, for on this one it's 400 milliamps, it shifts from maximum displacement to min displacement, nothing in between. It's on, off.
It's very strange. You hear them talking about this 400 milliamp. You're saying to yourself, well, it's either off or it's on. So what's this milliamp business? Are you going to give it only 300 milliamps and you don't want it to move, and then you're going to give it 400 and you want it to move? Well, that's how we're testing it. I would not think that in the field that would work that way. But it is a good test for us to make sure that everything's working internally. Now, in this case here, the 2-position and the proportional means that you could give it half the current and it would go to half the displacement. They're basically the same controls. It's just a few pieces that are missing in there that change it from proportional to this 2-position. EO is this 2-position. The EP is the proportional one. We're going to post a schematic of this one.
So did this motor come with an EP control, and did we switch it to an EO, or what exactly did we do here?
It came with a hydraulic control, and we switched it to an electronic one. The concept of them is really the same. It's just that on the hydraulic, it's a hydraulic signal that's saying to move it. But in this case, it's an electrical signal. So an electrical signal would be getting it from a electrical joystick or a computer like a PLC. Hydraulically could be maybe a foot pedal, for instance, or just a directional control valve.
I just want to confirm, Lloyd, you check the current here?
I checked the current, so it's basically boom, go to 400 milliamps, it shifts. Would you like me to show you? So you can visually see it and you know that it's correct?
Yes, I just want to see that it's happening at 400. So we are going to shift the displacement of the motor electronically. Lloyd is going to do that. It's going to send current here. Once I send enough, or 400, the motor is going to shift from low speed to high speed. In here, I'm looking at the current, the milliamps required.
Yep.
In here, I'm looking at the RPMs. It's supposed to be twice, based on the settings. Right now, he's in the minimum displacement. I know because the maximum displacement is supposed to run at 260 RPM. Right now, we are running, do you see? Now it's perfect. So that's maximum displacement, 280.
You watch your milliamps. So there's 200 milliamps almost. There's no change in my RPM, right? I'm at 280 still. I know, it's a little early.
Cannot we tweak the threshold spring from outside?
I don't think the threshold is going to tweak our beginner control.
It will.
No, because that's our modulating spring, isn't it? That's going to be the 400 bar where it shifts back.
$10.
You want to, I'll switch it if you want me to switch it, but...
When he puts 320 milliamps, it's shifting. Based on the motor code, customer wants to be shifting at 400. So he's just gonna change the setting on the spring, and that's supposed to increase our current required to shift. He said that it doesn't. That's why I said $10. So that's maximum displacement, 280. Now it's perfect. Now he owed me $10. I'm Martino.
The funny thing is, so Andreas is betting something that isn't really relevant. And Lloyd says that, but Lloyd, is always listening, so he just played along. I would not think that if it was a two position, that the machine manufacturer would ever say, well, let's give it half of the current to it. I would think that they would give it full current or no current. But it is a little bit of a test to see, is it functioning properly? Now, LIFCO is one of the few people that can test a motor like a motor. Most people test motors like a pump. Now, you can test it that way. In fact, I know a lot of highly qualified shops that do that. But we have the benefit of having a dynamic motor bench, meaning that we can apply a load to it and test this under load. I always call this test bench the old but gold. You could see me walking around there, sort of sticking my nose in things. Why is that? It's because I wasn't very familiar with these. At the time, I was looking for an opportunity such as this to start learning more about them. The best way to learn is to do a little problem solve and do a little testing. Say to yourself a hypothesis. Say, well, if I do this, I expect to see this. And do you actually see that? And then just understanding the schematics. Don't be scared of the schematics. Once you get the hang of them, they're a very powerful tool. I would not say I'm an expert on these. Nobody's an expert. If somebody says they're an expert, then you know that they're not one, because a truly highly specialized individual would never call themselves an expert because it implies liability. Experts are who you call to the witness stand in a court case. You do have a responsibility to make sure that the job is getting done properly. You have a responsibility to be learning about things and to be understanding.
So the way we confirm that everything is correct on this is that at 110 cc, we calculate how much RPM we should have at a given flow. We set the flow with our pump. Our RPM should be damn near bang on or very close.
Yeah.
And it was. Apply 400 milliamps to it. It goes from max to min. Efficiency's good. We have to confirm the flow rate because they want a specific flow rate, which is the non-standard. Everything seems to line up good with my math.
Yeah, check it. It's good.
Should be good.
This is a message to our loyal 20 followers. Thank you so much. I really appreciate that. We make the videos for you. We also make them for me. I did not know a lot of this stuff when I began. So with this sort of learning experience is something that I'm trying to share with you. The only thing is that you can't just, an 8-minute video is a little tough to pick up on it. So that's why we have the posts going and so forth. And just pick up a catalog and try to understand a few of the schematics as well. And choose Parker. We are trying to push Parker products, Parker and Lindy products here. Choose the Parker products and we can do this whole journey of learning together. Parker is a leading manufacturer of hydraulic pumps and components. We're a distributor for them. It's our main business. And they just awarded us Distributor of the Year for 2 separate divisions. We're beaming with pride.